It is the fuel of the modern world. Every year, humanity consumes over 180 million tons of it. It hides in our coffee, structures our pastries, and energizes our bodies. But have you ever wondered how a tough, muddy, giant grass standing 10 feet tall is transformed into the sparkling, pure white crystals sitting in your kitchen cabinet? Welcome to the Cathedral of Sweetness. This is a mega factory that operates 24/7 during harvest, processing a staggering 20,000 tons of raw sugarcane every single day. From the rugged fields to the microscopic lattice of a crystal, we are about to decode the high-speed engineering behind the world's most popular ingredient. The process begins in the vast plantations, but the clock starts ticking the moment the blade hits the stalk. Sugarcane is a living organism. The second it is cut, enzymes begin to eat away at the sucrose, converting it into useless starch. To combat this, the logistics here are military-grade. Trucks arrive in a relentless stream, dumping their loads onto the feeder tables at a rate of 800 tons per hour. This is the green tsunami, but the cane is dirty, covered in field mud, rocks, and leaves. Before it can be processed, it must be stripped. The cane enters a violent dry cleaning chamber. Here, powerful air blowers and tumbling drums strip away the leaves and trash. In some facilities, water jets at 60 pounds per square inch wash the stalks, ensuring that what enters the factory is not mud, but pure raw material. This input discipline is the first line of defense for quality.
Acknowledged. Control to all units. Divert auxiliary power to Sector 4. Maintain stabilization protocols.
Now, the physical transformation begins. We need to get the liquid out of the fiber. The cane is first fed into a high-speed shredder. Spinning knives turning at 1,000 RPM tear the hard stalks into a fibrous pulp. Rupturing the plant cells to expose the juice. This pulp then marches into the milling tandem, a series of 5 massive crushing units. Each unit consists of grooved steel rollers exerting 3,500 pounds per square inch of hydraulic pressure. It is a brute force extraction. As the fiber is squeezed, it releases a murky, dark green liquid. By the time the fiber exits the final mill, 96% of the sugar juice has been extracted. The dry fiber left behind, called bagasse, isn't wasted. It is conveyed directly to the factory's boilers to be burned. generating the steam and electricity that powers this entire beast. The factory effectively runs on its own trash. The extracted juice is currently an ugly, acidic, green sludge full of soil and impurities. It is time for chemistry. The liquid flows into the clarification station, where it is heated to 75 degrees Celsius and mixed with milk of lime, calcium hydroxide. The lime neutralizes the natural acids, preventing the sugar from breaking down, and traps impurities in a heavy flocculant. In the clarifiers, gravity does the work. The heavy mud sinks to the bottom, while the clear, golden juice rises to the top. This is the first glimpse of the gold. But this juice is mostly water, about 85%. To turn it into crystal, we must boil it. The juice enters the multiple effect evaporators. These are towering vacuum vessels. By creating a vacuum, the engineers lower the boiling point of the liquid. The juice boils violently at just 65 degrees Celsius instead of 100 degrees Celsius. This is crucial. High heat would caramelize the sugar, turning it brown and bitter.
Keep an eye on the temperature gauge, it's spiking again. I see it, adjusting the flow rate.
The water vapor is sucked away, condensing the liquid into a thick amber syrup with a sugar concentration of 65 bricks. This is the heart of the operation, the vacuum pans. The thick syrup is boiled again under an even tighter vacuum until it becomes supersaturated. Here, the master sugar boiler injects microscopic seed crystals, tiny sugar dust that acts as a blueprint. Suddenly, billions of crystals bloom and grow, suspended in a heavy brown molasses. This mixture is called massacute. But we don't want the brown molasses. We want the white crystal hiding inside it. The massacute drops into the high-speed centrifuges. These are perforated baskets that spin at a dizzying 1,200 RPM. The physics is identical to your washing machine's spin cycle, but on steroids. The intense G-force flings the heavy liquid molasses through the mesh screen, while the solid sugar crystals are trapped inside. In seconds, the color shifts from dark chocolate brown to a blinding snowy white. It is a moment of pure industrial satisfaction. A quick spray of hot water washes away the last film of molasses, leaving behind raw sugar with 99.5% purity. The sugar is now white, but wet. It travels to the fluidized bed dryer. Hot, filtered air is pumped from below, lifting the crystals so they float on a cushion of air. This gentle tumbling dries the moisture content down to a precise 0.04%. The crystals are now free-flowing and cool. Finally, they pass through a battery of magnetic separators and screens to ensure no foreign particles remain. The packaging line is a blur of automation. Robotic arms fill, weigh, and seal bags at a rate of 3,000 units per hour. Nitrogen flushing removes oxygen to ensure the sugar stays loose and fresh for years. From a muddy stalk to a sealed packet, the process is complete. What began as a chaotic harvest of giant grass has been tamed by thermal dynamics, centrifugal force, and chemical precision. This facility doesn't just make sugar, it orchestrates a transformation of energy. The next time you stir that teaspoon of sugar into your morning coffee, remember the 20,000 tons of pressure, the vacuum towers, and the spinning tornadoes that made that simple moment of sweetness possible. This is the sweet science of modern survival. If you want to see more mega factories turning raw nature into daily essentials, subscribe to Global Food Tech and comment below on what we should process next.
The taste of pure crystal sugar, so sweet and bright.